this video session we are going to see solar electric conversion and its application. So energy from the sun is transformed into electricity either by solar thermal or ocean thermal or photovoltaic or wind conversions. So here we are going to see about the solar thermoelectromechanical conversions and solar photovoltaic, how heat energy is converted into electricity and photovoltaic is converted to electricity. So solar energy can be used for generation of electricity in two ways, either by using solar cell or by using the some kind of electromechanical conversions. So first we will see the solar thermoelectromechanical conversion, that is we are converting solar energy into heat and heat to power. Solar energy is converted to heat to power, that is thermodynamics. So heat into power in the sense heat will be applied to the turbo generator where the heat is converted into mechanical energy is converted into electrical energy. So solar thermal energy is concentrated and transferred to working fluid for the use of either Rankine cycle or Brayton cycle for the turbine generator. So turbine generator, before the turbine generator, there is a Rankine cycle or Brayton cycle will be connected, where this cycle is used to convert the mechanical motion into electricity. Because the turbine connected to the generator, so mechanical motor, that means the shaft rotates inside the mechanical motion. So the shaft which is connected to the generator also rotates and generates the electricity. So most of the solar thermal energy development is towards obtaining some kind of heated fluid. Instead of using water, we are using some kind of fluid where more amount of steam will be generated. That steam will be passed through this turbine, in the sense the turbine starts to rotate. The shaft will starts to rotate because of the more steam. So it starts to rotate, then it is connected to the, that means heat energy is converted into mechanical energy. Then the turbine is connected to the electrical, that is nothing but the generator or an alternator in the sense. Then that will be converted, the mechanical energy is converted into electrical energy. So solar collector for direct heating applications, for heating fluid we can use it. Sometimes the combination of both also can be used for direct heating as well as indirect heating, also used for generation of the electricity. So normally what kind of engine, heat engine is used, in the sense a Rankine power cycle engine is used, or otherwise a Brayton heat cycle is used. This is nothing but normal solar conversions. So the sun radiates onto the concentration discs in the dish, which will collect the solar rays and it will be reflected back to the collector. There is a central receiver or a boiler which has the collector. In this boiler, the fluid will be pumped to the boiler with the help of pump. So the fluid enters into the boiler, becomes a steam, high pressure steam. That high pressure steam is given to the turbine. That steam rotates the shaft in the turbine, which is connected to the generator where the electricity is produced to the load. Once the shaft is rotated, in the sense the steam, the high pressure steam will be going to the condenser as a low pressure steam. So here the steam is again converted into water or a fluid with the help of condenser. So it may be ammonia or it may be propane or whatever it may be, that like that the fluid will be converted. Again that fluid is pumped by the pump to the boiler. So this process is repeating for generation of electricity. That is nothing but solar thermal electrical mechanical conversion. That means heat is converted into electricity. So for that we are using basic Rankine cycle. So Rankine cycle is a thermodynamic cycle which is used to produce the electricity in many power stations. Sometimes Carnot cycle also be used. So superheated steam generated in the boiler, then expanded in the steam turbine. The turbine drives the generator to convert the work into electricity. The remaining steam, when high pressure steam is rotating in the sense, then it becomes low pressure steam. So the remaining steam is again condensed and recycled as a feed water to the boiler again. What is the disadvantages in the sense? Using this water steam mixture, the superheated steam is to be used. Otherwise, moisture content after expansion might be too high, so which will erode these blades, which will make corrosion in the blades. Instead of water, we can use some kind of organic fluid, but major advantage of the organic fluid is it has to be used below 400 degrees Celsius, do not need to overheat it. Many cases superheating is not required, resulting in higher efficiency of the cycle. This is also called as organic Rankine cycles. The most common power cycle used in the solar power system is a Rankine cycle, which combines constant pressure heat addition and rejection process with adiabatic reversible compression and expansion process. It utilizes the working fluid that changes the phase during the heat transfer process to provide the essentially isothermal heat addition and rejection. The heat working fluid may be used as either water or some kind of organic fluid. The major component of the ideal Rankine is nothing but working fluid, temperature entropy. So we have to see that the basics of the Rankine cycles. The pressure saturated level leaving the condenser at state 1. State 1, the pressure of saturated liquid leaving the condenser at state 1 raised in an adiabatic reversible process by the pump to the state 2, where it enters through the vapor generator, also called as a boiler or steam generator. The compressed liquid is again heated at the constant pressure called preheat station until it reaches to the saturated liquid state 2. Then at constant pressure and temperature, the liquid has to be vaporized and become saturated vapor at 3. More heat is added to the superheat the saturated vapor at constant pressure. The temperature rises to state 3 and superheated vapor now enters into the turbine and expands the adiabatic reversible process to the low pressure maintained condenser again on state 4. So the condenser converts the vapor leaving the turbine to liquid by extracting heat from it. Often during the expansion, the process, the vapor reaches to the saturation condition as a mixture. So this is state 1 and state 2, again state 2 to state 3 and state 3 where low pressure will be generated, again it will come to state 4 and it will be converted into liquid. So the requirement for the superheat, the vapor from state 3 to 3 is nothing but the amount of moisture that is permitted in the expander. Exhaust from state 4 to 4 dash. So if the expander is high speed turbine, then wet vapor produces a destructive erosion of the blades. Some type of expanders such as piston and cylinders are also be used. So process 1 and 2 in the sense the working fluid is pumped from the low to high pressure. As a fluid of liquid at the stage is pumped requires the little bit input energy. Process 2 to 3 is nothing but high pressure liquid enters into the boiler and the input energy required can be easily calculated by using this one. And process 3 to 4 is nothing but the dry saturated vapor expands through the turbine generating the power. Process 4 to 1 is the wet vapor enters into the condenser and to become the saturated liquid. The next one is photovoltaic conversion, that is light to power conversion. So solar cell which delivered to the which is delivered that means the sun radiates the energy that will be collected by the solar cells, which will convert it into electric current. This electricity can be either used to store the battery or it can be used directly. The stored electricity energy can be used in the number of applications like domestic applications, street lighting, village electrification, water pumping, desalination of the salty water, railway signals, powering up the remote telecommunication repeater stations, and to meet the electricity requirements. Thank you.